Welcome to this VMworld 2021 code session dedicated to NSX-T and infrastructure as code. My name is Nicolas Michel, and I'm a technical product manager in the networking and advanced security business group, and I am thrilled to present this session about NSX-T and infrastructure as code. What I would like to take the opportunity today to really demonstrate what I'm doing on a daily basis when I want to deploy a topology and leverage infrastructure as code. Really, you will see that you will get so much of your time back, and you will be able to deploy infrastructures with the consistency and without any error. Make sure to use the hashtag code2741 online so that I can answer all the questions that you may have after the session. A quick look at our usual disclaimer, and let's jump right into the topic. So you will hear me saying this a lot during this session, but it's really important to make an assessment, right? When you want to code something, to deploy something, obviously, first you need to make an assessment of all the steps needed to configure your particular topologies or your particular infrastructure. Well, here we are going to deploy NSX-T. We're going to deploy the infrastructure, but also all the network, the construct, and the virtual machines that will be needed to test our connectivity. So first, you need to install the OVA template, right? You need to deploy that OVA on a vCenter environment that will install the NSX-T manager, right? Also, you need to create all your basic configuration of NSX-T. You need to create your IP pools for the tabs. You need to create your profiles, your license, your uplinks, etc., etc. Then comes the networking construct, like the overlay segments, the VLAN segments, so that you can have connectivity towards your top of racks. You need to create your tier 0, your tier 1s, and what kind of configuration do you want on your tier 0 and on your tier 1s? Do you want to have your tier 0 in active, or in active standby? What kind of, how many interfaces do you want on that particular tier 0? What dynamic routing protocol are you going to use in that particular NSX-T domain? So you need to think about that before the deployment itself. What BFD timers do you need to configure so that you can match what's configured on the physical fabric? You need to think IPv6 as well if you have some IPv6 workload. And the rationale behind that is that you want to replicate your test, dev, and prod environment, right? You want to test something in NSX-T in your dev environment, and you want to make sure that that exact same configuration, exact same versioning will be applied to your production environment. And that's what I like about it, because when I test a new feature, I'm able to test that feature in a particular version, so that with infrastructure as code, I can go back and make sure that feature was also working in another particular version. So I'm able to be flexible regarding the versioning of my infrastructure here. And we really want to leverage infrastructure as code, because doing everything manually is very complicated, right? You have a lot of steps that you have to think, you have to follow a plan, and it will cost you a lot of time, and sometimes you will make an error, you'll make a typo, and the typo will not be at the same place where you were thinking of, and maybe you will do another typo next time, but on another networking construct. So really, the idea here is to be flexible and consistent between your deployments. So at the beginning, you will struggle a little bit. I was struggling a bit when I was building my code. On the first 2 times, I would say I would be faster doing all my operations manually. But now, as I mentioned, I can deploy any topology in a really short amount of time. For example, in my lab, it takes me approximately an hour to really install NSX-T in my lab environment with virtual machines and networking construct in mind, so that I can have any version of NSX-T up and running pretty quickly. It is also really important for professional services where you want to have a baseline for your infrastructure as code, and then you can tweak between your deployments some parameters, for example. So infrastructure as code, there are many tools where you can do infrastructure as code of today. You have Ansible, the Terraform SourceStack, Puppet, Chef. So why not using just one tool? Well, the rationale behind that statement is that there is not one single tool that can do everything perfectly, right? So in this example, in this demo, I will focus on what each tool can do well, right? And I'll show you how to use them. So for example, if I want to use Ansible, Ansible is very good at provisioning my NSX-T infrastructure. So when I want to deploy my NSX-T manager on vCenter, etc., etc. So Ansible really excels in that particular all these kind of tasks. For if I want to create all my networking construct, my logical topologies within NSX, then Terraform is very handy. I can deploy, it supports EVPN, it supports OSPF, it supports BGP, of course. So Terraform is very handy in that particular case. And my intent is really declarative, really easy to understand in the Terraform, and can be applied after that really easily and very, very fast. Also, the troubleshooting in the Terraform is pretty easy. Whereas it's a little bit more complicated if you run Ansible. I'm also running REST API in these demos because, well, native REST APIs, because some parameters are still not supported by the Terraform, for example. So, and then when my networking construct are configured, when my NSX-T infrastructure is deployed, I will be able to deploy some virtual machines so that I can use some workload and test my connectivity. And for that, I will be using the Packer and the Terraform as well. It's important to mention that all these tools are leveraging the REST API that is built within NSX. So in order to understand that, when we build NSX, we build the API first. Right? We don't build the UI first and then the API. No, that's the other way around. We build the API so that every feature that we test first, we test them using the API. And then on top of that, we build the UI so that you can leverage graphical user interfaces for your deployment as well. It's up to you. But you have the policy API where with a single API call, you are able to create multiple objects, for example. So if you want to see which API call is being made by the graphical user interfaces, it's very simple. In this example, I'm creating a segment, an overlay segment with a name, a transport zone, and a subnet, right? So that's the only thing I'm doing. Then if you enable the debugging tools that you have, it's in Firefox here on this example, so you can see the actual API call that is being made. You just have to replicate that in your software, in your code, if you want to deploy that same particular segment, for example. And I described it, the two URLs that you will see here will be useful if you want to see every API calls that are available for NSX-T as of today. And for each particular versions, right? So I've mentioned multiple tools, right? So you can install all these tools onto your virtual machines, onto your laptops. It's up to you. What I'm currently doing is that I created my own container. I have my own container that I use for all my automation tasks. So everything that you will see here will be performed using my own container. In this container, I have the Terraform, I have Ansible, I have Python, I have Vault. But the idea here is that I also treat that container with infrastructure as code, meaning that if I want to upgrade, the Terraform, for example, in this container, I just have to kill that container, change the versioning in my code, and just rebuild that container. And when I launch this container, well, that new container will run the new version of the software that I decided to upgrade. So really useful. And all the code that you will see today will be available to you so that you can see some examples. And that's the actual URL that where the code will be available, of course. So do not hesitate to ask me any question after that. So let's start with Ansible. So as I mentioned, we need to deploy our basic infrastructure. Ansible is not a new tool, so it's pretty well known in the industry as of today. So just a quick slide to remind all the concept about Ansible, so you have the inventory, will run the Ansible playbook locally here. You have all the tasks, and the task here will have a module which will be the NSX-T deploy OVM module, right? That's a module that's been provided by VMware. And the task here where we show all the variables, right, on the variable file, we need to think about these variables when we want to deploy our NSX-T manager. So that's the DNS server, the domain, the IP addresses, the subnet, etc., etc. And then you run that playbook, and that will install the NSX-T manager. So here in my playbooks, I have a collection of playbooks where I will install my NSX-T manager. I will also configure that NSX-T manager. So the first step would be to apply a license on that NSX-T manager. Then I will also register my vCenter on that NSX-T manager. I will then create my uplink profiles. I will create my IP pools. I will create my transport zone, and I will install. Then, as soon as I have that, I will install NSX-T on all the hypervisors of my compute cluster. I'm going very quickly here because I will repeat that when I'll do the demo. So then I will enable IPv6 and deploy my edges, and then put my edges into the edge cluster. So let's go for it. So here, as you can see, I'm running my Ansible playbook on my container that's running on an actual container, and I'm deploying my NSX-T manager on the vCenter, as you can see here. So it uploads the OVA, and we'll configure this NSX-T manager based on all the variables that have been specified into my answer file.yaml. So here I'm doing the vCenter registration to NSX-T manager. I could do that with Ansible, but I just wanted to do it with REST API natively. So that script will have a mix of Ansible and REST API, just to show you the different possibility here. Then I'm applying the license. I'm configuring my uplink profile for my compute cluster with a multi-tap, right? And I will also create another uplink profile for my edge cluster with a multi-tap, but also with two name teaming policy for my BGP traffic. So we want the traffic to be deterministic towards top of rack 1 and top of rack 2. And then I will create my IP pools, one IP pools for my edge cluster and one IP pool for my compute cluster. I create my transport zone, my overlay, and my VLAN transport zone, right? And then I will install NSX-T. I will install NSX-T on our hypervisors, right, in the compute clusters. So it's doing that. So with one single playbook, I can say I want NSX-T to be installed on hundreds of ESXi servers, for example, so which is very, very handy. Then I will enable IPv6, right, in our fabric, and I will set the MTU to 9,000. I will create two edge clusters, one edge cluster for the bare metal edge and one edge cluster for the virtual machine, for the edge node on the VM form factor. And for each of them, I will be able to specify my BFD timers. Then I'm deploying my NSX-T edges. In this case, I will deploy 6 NSX-T edges, as you can see. So I'm doing that fast forward. And I will be able to then group this edge node into clusters. Right? So edge cluster 1 will have edge node 1 and 2, etc., etc. So it's doing that. And then after that, when that playbook is completed, I will log into my NSX-T manager and be able to really check if my configuration is done. So as you can see here in the networking overview, I don't have anything except the IP pools. So my two IP pools for my TEP and my edges. I've seen that I successfully enabled IPv6 in my environment and the MTU for the gateway interfaces is set to 9,000. The network topology is empty. So that's what we are going to focus on. The next step is that we're going to build a networking construct with Terraform. You can see that NSX-T has been successfully installed on the edge on the compute cluster. I have my 6 edge nodes and my 3 edge clusters, and I have all my profiles that have been that have been used in order to deploy these edge nodes as well. I have my edge cluster profile, my transport node profiles for my compute cluster. So yes, everything has been successfully configured, and as you can see, not a single click has been done from a configuration standpoint here. Right, I have the registration to my vCenter, so it's up and registered, and now we will be able now to really focus on the topologies from a networking standpoint that we want to see with NSX. So then we are going to use the Terraform for that. So that's the topology that we are going to work on today. It's pretty simple the topology where we have multiple tier ones. So we have a multi-tier routing architecture. We have 4 tier ones, and we have 2 tier 0. One tier 0 will be in active mode on edge node 1 and edge node 2. The other tier 0 will be in active mode running on edge node 3 and 4, right? And between the top of racks and the tier 0 on the edge node and the tier 0 SRs, I will have some /31 uplinks, right? So I will need to take that into consideration when I create my segments, because one uplink towards my top of rack will equal to 1 segment as well. And on the top right of the diagram, you can see we have a virtual machine that will be useful if we want to test our north-south connectivity to our virtual machines. And on the south, so we have our tier ones with multiple overlay segments. So each tier one has 3 overlay segments, one for the app, one for the DB, and one for the web. And we are going to install virtual machines into each of these the tier 1 overlay segments. So let's do that. We'll do that with Terraform. Same as before. I will go very quickly on this slide because the Terraform is not a new tool, but it's in my opinion that's the best tool for this kind of job. If you want to deploy all your networking construct, Terraform is the tool that you need to take into consideration. A special mention to Vault, where all your variables that you want to use for your deployment, you can either put them into the Terraform, but that will be in the clear test, or you can definitely use Vault so that your variables are protected. And that's the highly recommended way of setting up your NSX-T infrastructure. So here we have the NSX-T provider. You have all the information about the NSX-T provider for the Terraform. You also have the data source, but what's really important here to understand is the resources. So the resources is the actual object. That's the networking construct that you want to declare, that you have the intent to install within NSX, to configure within NSX. So as you can see here, we have a logical switch web that we want to declare. So same step as before with Ansible, we need to think about all the networking construct here that we want to configure in our NSX infrastructure. We'll have to configure our VLAN segments, our overlay segments, the tier 0 creation, what BGP configuration do we want, what high availability mode do we want for our tier 0, the neighbors that we want, the autonomous system number of our tier 0 and the autonomous system of the BGP neighbors, for example. Which BFD timers do we want? So that's something that we need to think before we actually create the code. We need to take into consideration all these variables when we want to create the code, because this has some implication. Let's have a look at how the code looks like. So here I have my resources for my VLAN segment, for my tier 0. I also have my resources for my interfaces, and really important for my BGP neighbor. Same thing for the tier 1 and for the overlay segment. Here you can see I'm going to enable IPv4 and IPv6 on the same overlay segment. So I will run dual stack IPv4 and IPv6 on this overlay segment, and you will see that with this playbook, with the declaration of this networking construct, I will be able to provision an IPv4 and IPv6 infrastructure within NSX really easily. So let's do it. So if I do a Terraform plan, the Terraform will make an assessment on what's my intent. What's my intent? How many objects how many resources do I want to configure within NSX-T? And it will check what's the current state of my NSX-T solution. And here you can see it plans to add 55 objects. So I will apply. I will do a Terraform apply so that that's my intent. I will declare that yes, this is my intent to apply these 55 objects. So I'm doing it, and you can see it's pretty quick. I'm creating all the VLAN segments, all the tier 0 gateway, the tier 1 gateway, my BGP configuration, my external replica interfaces, all that within a single the Terraform the command, and very easily and very fast. So now if I have a look at the NSX-T UI in the network overview, you will see that I have a little bit more. I have my 2 tier 0, my 4 tier 1s, I have all my segments. You also need to take into considerations that when you push a large config, it takes a little bit of time for NSX-T to configure all these objects in the database. The realization state is really important here. And you can see in my network topology with my single API command, with my single the Terraform, the command, I was able to really do all my networking construct and create my own topologies. So you can see here I have my BGP configuration and all my BGP neighbors are already established. So now if I'm logging to the edge 1, for example, if I do a get logical router, I will be able to connect to VRF 15 in my case, which is the VRF for the tier 0 SR, and I will be able to really check what's the for example the BGP neighbor status. So I can see that from an IPv4 standpoint, I'm connected. I have 2 BGP peers. I'm at 2 top of racks, and I'm exchanging some prefixes. But same thing from an IPv6 standpoint. I have the same 2 BGP neighbors. So if I do a get BGP neighbor to see the BGP table, I will see both my NLRI for the IPv4 prefixes and IPv6 prefixes. Then I just have to check that these prefixes are installed into the routing table of that particular tier 0 SR, which is the case actually. And these tier 0 SRs, I can verify that I have internet access, right? So routing is established to my top of rack fabric, and everything has been done without a single click. That's really the beauty here of having automation, is that you can do everything automatically and provision your network topologies pretty easily. All right. Next, when I have so we have our network. Well, we have our networking construct deployed with Terraform. We have our NSX-T infrastructure that has been previously deployed using Ansible. Now we need some virtual machine in order to test the connectivity, the north-south connectivity, and east-west as well. So for that, I will also leverage infrastructure as code. I will create a template on my vCenter environment using Packer, right? It will build an image with all the parameters that I want, the number of CPU, the disk size, the RAM, etc. Well, the memory, etc. And it will create a template. Then it will shut down the template to be reused after that by Terraform. So when I create my Packer template, first it will download the ISO that are specified. So here the base is based on the Ubuntu 18.04, and it will re-upload that ISO on vCenter, right? On the ESXi2, for example, here it will create the VM, right? It will install a VM, and that VM will be used as a template. So you're pretty familiar with all these screens if you already installed Ubuntu. It will wait for an IP. So you need to have a DHCP in that particular VLAN where you create your template, because after that it will take control of the VM, and it will just install all the software needed, like updates, etc. Then the VM will be shut down, and it is at this moment when the VM is shut down that you can reuse that particular template using the Terraform. That's what we are going to do here. As you can see, I'm creating 3 VM. In this example on this slide, I will create more in the demo, but here I'm creating 3 VM, one for the web, one for the app, one for the database. And the only thing that changes here is the host name, the subnets, the IP addresses, etc. And obviously, one thing that is also really important is the overlay segment that each of these VM will be connected to, because these 3 VMs will be in different overlay segment within NSX-T. So let's do a Terraform, same thing. Let's do a Terraform plan, and Terraform will identify my intent. How many VMs do I want to create? In this case here. So I do a Terraform apply, and I confirm with a yes that I want to configure and to deploy these 8 virtual machines, and it will create this virtual machine on my cluster. In the meantime, on my virtual machine is outside of NSX, I will do a ping so that I can test the IPv4 connectivity between that VM is outside of NSX and the VM that I'm deploying right now. And as you can see, we have the network the connectivity here. And we have the network connectivity here from an IPv4 standpoint, but we also have the connectivity from an IPv6 standpoint. So we were able to provision both IPv4 and IPv6 at the same time without a single manual intervention. If you want to bring down that environment with Terraform, that's really simple. You can do a Terraform destroy, but just before we do that, you can see in NSX the virtual machines are discovered, and you can see plenty of information. You can see the IPv4, IPv6 address and the MAC address of the VM and the VIF on which VIF it is attached. So if I do a Terraform destroy, it will bring down this virtual machine. And if I do a Terraform destroy on my previous task where I was deploying my networking construct, I would also be able to delete all my networking construct from NSX, the segments, the BGP configuration, etc. So that's why I find it very useful when I want to test multiple topologies very quickly. That was a lot of information. I totally understand that, but trust me, it is very valuable to use automation in NSX-T. You will get plenty of your time back. I can assure that. And again, you will have the flexibility to create multiple topologies with an infrastructure as code and to have the consistency that you want between your different infrastructures, dev, test, and production environment. So it's really useful. Do not hesitate to send me a tweet using the hashtag code 2741, and I will be very happy to answer all of your questions. Please take your survey, and I thank you very much, and I really hope you enjoy VMworld 2021. Thank you very much. Bye-bye.